All right, let's dive in. Today, we're going to master one of the most critical, fundamental building blocks of programming, Python loops. These are the tools that take all those tedious, repetitive tasks you hate and turn them into automated, really elegant solutions. Let's get right to it.
So have you ever found yourself writing the same line of code over and over and over again? It's not just boring, right? It's a total recipe for typos and frustrating bugs. Well, this is the exact problem that loops were invented to solve.
And this right here, this just perfectly shows you the power of loops. I mean, look, manually typing print hello 3 times isn't just a pain, it's practically asking for a mistake. But with a simple for loop, bam, same result, 2 clean lines. This is what iteration is all about, writing less code to do more work and doing it way more reliably. Okay, so let's kick things off with the undisputed workhorse of Python iteration, the for loop. This is going to be your go-to tool whenever you have a collection of items and you need to do something with each and every one of them. You know, this quote really gets to the heart of Python's whole philosophy. Instead of making you juggle counters and indexes like some other languages, Python's for loop is all about a for each idea. It just works directly with the items themselves, which, let's be honest, is a much more intuitive and readable way to think about code. So what's actually happening behind the scenes? Well, it's this wonderfully methodical process. A for loop basically asks the sequence, hey, give me your next item. It takes that item, assigns it to a variable, and runs your code. Then it asks again, okay, what's next? And keeps doing that until there's nothing left. It's completely automatic. You don't have to worry about the details.
And the real beauty of the for loop? It's sheer versatility. It honestly doesn't care what kind of sequence you throw at it. You can loop over items in a list, you can loop over characters in a string, a sequence of numbers from range, or even the key-value pairs in a dictionary. It just works.
Oh, and let's talk about range for a second. This function is so efficient. If you tell it to loop 1,000,000 times, range doesn't actually create a giant list of 1,000,000 numbers in memory. No way. Instead, it just generates each number as the loop asks for it, one by one. This makes it perfect for looping a specific number of times without gobbling up all your computer's resources. So the for loop is awesome when you know exactly what you're looping over, but what if you don't know ahead of time how many times you need to repeat something? Well, that's where our next tool comes in, the while loop. This guy doesn't loop over collection, it loops as long as a certain condition stays true.
The rule for a while loop is super simple. As long as the condition you give it is true, the code inside the loop will run. The second that condition becomes false, the loop stops dead in its tracks. This is perfect for stuff like waiting for a user to type something or processing data until you get a specific stop signal.
But, and this is a huge but, you are the one responsible for making sure that condition eventually becomes false. If you don't, you've just created an infinite loop and your program is going to get stuck running forever. Now, sometimes you do this on purpose, like in a game loop or a server that's always listening, but usually it's a bug you really want to avoid. So how do you pick which one to use? Honestly, the choice is usually pretty straightforward. If you have a collection of items, a list, a string, whatever, and you want to process each one, the for loop is your best friend. But if you need to just keep doing something until a situation changes, a while loop is exactly the right tool for that job.
Okay, now that we've got the basics down, let's open up the toolbox. Python gives us some special commands that let us fine-tune and really control the behavior of our loops while they're actually running.
First up, nested loops. This is just a fancy way of saying a loop inside of another loop. It's pretty simple. For every single time the outer loop runs, the inner loop will run all the way through to completion. This structure is absolutely essential when you're working with 2D data, like, say, the rows and columns in a grid or the pixels on a screen. Next, we have break and continue, and it is so important to know the difference here. Think of break as the big red emergency stop button. It just kills the loop immediately. Game over. Continue, on the other hand, is more like a skip button. It stops the current round right where it is and jumps immediately to the top of the next one.
And then there's pass. Now this one might seem a little weird at first, but it's super useful. The pass statement literally does nothing. Its whole job is just to be a placeholder. So if you're sketching out a loop or a function and you haven't written the logic for it yet, you can just stick a pass in there to keep Python from complaining about the syntax.
All right, so you've got the fundamentals down pat. Now let's level up and look at a few pro moves. These are techniques that are considered more Pythonic. That just means they're cleaner, smarter, and really the way experienced Python developers write code.
Now here's a really unique Python feature, the else clause on a loop. And don't get this confused with a normal if-else block. This else only runs if the loop finishes its entire run without ever being cut short by a break statement. This is amazing for things like searching for an item in a list and then needing to do something special only if you didn't find it.
This is one of my absolute favorite features in Python, list comprehensions. Okay, so on the left, you see the standard for loop way to build a list. It works, it's fine, but it's kind of wordy. Now, look at the right. The list comprehension does the exact same thing in one single, elegant, readable line. It's not just about being shorter, it's a much clearer way to say what you're trying to do, and a lot of the time, it's faster too.
Finally, let's go over a few common mistakes to watch out for. First, that dreaded infinite while loop. Always double-check that your condition will eventually turn false. Second, be super careful about changing a list while you're looping over it. Trust me, that leads to some very confusing bugs. And of course, the classic off-by-1 error with range. Just remember, range of 5 gives you numbers 0 through 4, it does not include 5.
So we've gone on a whole journey, from the basic for loop all the way to some really advanced Pythonic techniques. You now have the power to automate, to process data, and to build things in ways that were probably impossible before. So the only real question left is, with all these tools in your hands, what are you going to build?